Detection as code has emerged as one of the most prominent detection engineering concepts in recent years. I personally first encountered it during my time as a cloud threat detection engineer at Datadog. So what exactly is detection as code? Detection as code is a modern approach to security detection where detection logic is treated like software code. This means that detection rules and alerts are written, versioned, tested, and deployed using software development practices and tools. Detection as code offers several key benefits like version control through systems like Git, allows detection rules to be tracked, versioned, and rolled back, ensuring transparency and accountability. Automated testing enables detection logic to be validated before deployment, helping to reduce false positives and improving reliability. And with this, you have reproducibility, which ensures that the detection rules remain consistent across different environments and teams, and you can easily move between vendors as necessary. This also helps with collaboration so that teams can review, contribute to, and improve detection rules using familiar development workflows. Finally, you also have continuous integration and deployment, or CI/CD pipelines, that allow detection rules to be automatically deployed and updated, thereby helping increase the efficiency of a detection engineering team. And this whole approach transforms security detection from a manual ad hoc process into a systematic engineering-driven practice that scales better and produces more reliable results for a detection engineering practice. Dennis kindly shares practical hands-on knowledge based on concept from his book, and in this video, we explore two detection as code CI/CD pipeline demonstrations. The first lab demonstrates some synthetic AI testing capabilities using Sumo Logic, while the second lab showcases integration testing using policy as code with Cloud Custodian and GCP. By the way, if you're not familiar with policy as code, it's an approach where infrastructure security policies are defined and enforced through code, allowing automated compliance checks and security controls across cloud environments. Before we begin, you don't have to worry about anything at all. You'll be able to try it out yourself. So I've linked the GitHub repos for this content, Dennis's book, our podcast episode together, and my review of his book in the description below. And these resources should be helpful alongside this video. Also, feel free to reach out in our Discord community of over 6,000 members if you need any help. And be sure to subscribe to the newsletter and keep an eye out on our store for the next CyberWorks merch collection. Thanks to everyone who supported the winter collection. I am super pumped to release the summer collection. That being said, let's dive into the first lab where we explore building SIEM detections with synthetic AI tests. All right, thank you so much for doing this, Dennis. I know in our last conversation, we're talking about automating security detection engineering, the book and everything, but we also talked about, and we kind of teased actually doing some, practical hands-on demos around some of the things that were in the book, but also some of the concepts that we talked about during the last podcast. By the way, if you've not seen the last podcast, definitely check it out. It'll be somewhere on the screen or a link in the description. But what are we going to be diving into today?
Oh, so you guys are in for a treat. I'm going to do two pipelines, and we're going to do two different runners and different types of testing in between, along with deployment. So you get the benefit of kind of like the book in one nutshell, but also like some extras that you guys might want to be interested in, which is the synthetic AI specifically with two different AI, generative AI LLMs. And then we have policy as code testing, specifically with integration testing built in. Just want to make sure we are sharing the correct screen.
Oh yeah, I can pull this
Okay,
up
cool.
here. There
Awesome.
we go.
Yeah. So for the first thing, for those of you that are joining us, just be sure to grab the GitHub items. And so I'll kind of just show you the GitHub repos. Just find it in my GitHub. It's public facing. It's called CWX Demo Sumo and
Yeah.
CWX Demo GCP. We're going to be doing this first one right here, and I'll walk through this. So for those of you watching, just go ahead and download the whole zip file there, and I'll show you what to do thereafter and some of the important files that goes with it. So once you build a GitHub repo, we're going to simulate a commit and push, create the action runner. I'll walk you through the synthetic test, and then we'll see the deployment of the actual use case inside Sumo Logic. All of this is free. Even though Sumo Logic has a 30-day free trial of the full edition, we'll be utilizing the free edition modules only. But just know that the paid edition comes with much better stuff. PoE, you do need to have a subscription or at least a trial of it if you want API key, and that's what we'll be using for our secret there. In lab 2, and you guys can find this the repo there on both of them, there's a full setup including requirements that I walk you through. Just kind of take your time doing that if you're doing it manually outside of this video without cloning anything. Lab 2, I'm doing policy as code, so we're going to use Cloud Custodian, which is free. They made Capital One made it, so you can do this across GCP, AWS, and Azure. And we're going to be using GCP because it's something new, and I think not a lot of people use it. And it's also easier, I think, cloud-wise for a lot of newcomers. So with that in mind, yeah, that's about it. Let's you want to get started?
Yeah, let's do it. Let's get into the first one.
All right, cool. All right. So those of you who have downloaded this, you're going to go ahead and make sure you have all this extracted. What I want to show you here is a few things in very important specific files in here. So just follow along with me. I'm going to just open this in my browser because it's easier to see. No one look at my search history. Ah. Okay, so we have the README file. It's all markdown, and it'll give you some more details about that. The lab guide's here, guys. So just look for that. But more importantly, I'm going to show you some very important files, regardless of the pipeline. At least when it comes for GitHub action flows. So GitHub action flows just means CI runner at the end of the day. And some of you may know this, some of you may not. It always is hidden. So because I'm the public repo owner, I'll see this, but you won't see this. But you will see this when you download the .github or you
Mm,
do your own clone. So you want to upload that as well. So don't forget to include that in your upload. So what I typically like to do is, if you're following along, just go ahead and use your free account, create a new repo. You can still keep it public. I think they gave you 200 minutes for free. Call it something unique that's global to GitHub. Set your description and whatever. And once you create it, you're gonna upload all of these files together and do a commit, do your first commit. It won't trigger the pipeline, and we'll trigger it manually as if we were doing this with a net new detection. I just want to show you some of the most important files. So in Terraform is something we're going to be utilizing right now. And so why are we using Terraform? It's great for an introduction. It's great for small companies and individuals. And if you don't know a lot of other coding and you want something that's just nice and packaged, a lot of cloud native and cloud services use Terraform. So
yeah,
Sumo Logic is one of them. Unfortunately, Splunk is not one for the detection side yet,
right.
but Datadog and many other SIEMs do that. So keep that in mind that there's nothing wrong with using Terraform for beyond infrastructure as code. So I have our GitHub action runner right here, and it's simply a YAML file that acts as an orchestration unit right here. And this orchestration unit is just a large tree of another script. So when we're thinking about pipelines, just think about that. You put something in a repo and a bunch of events occur, just like a serverless function, and we glue code a bunch of scripts together. That's all it really is at the end of the day. Now, those scripts and how good your pipelines are dependent on us as DevSecOps or platform engineers with our detection. More importantly, the name in here and the event itself. So you notice that we are pushing to the main branch. We don't go into branching or anything strategies like that, but this will help you with your first one. More importantly, we're also deviating from just any kind of push that a lot of people show you. I say best practices are saying you want to only make those tests for build spec JSON and your detections. This dot asterisk right here is made for subfolders. And so
Hmm.
I like to keep my stuff organized whenever possible. Now, another best practice I like to give to everyone is that you can have an all-in-one repo with multiple use cases, multiple technologies, and multiple pipelines and scripts. But it gets really cumbersome really fast. So you don't have a penalty against you for creating multiple repos. So
Right.
I like to keep them organized at that level, but you can do what you want. Now, don't make sure you don't delete this workflow dispatch. Even though it looks like it's out of place, it's the only thing that'll allow us to actually trigger manually inside the web UI. So if
Mm,
you're not used to the CLI client, you use this. And then one thing that I think the if you're new to detection as code, or at least new to coding in general with secrets management, all of us use environment variables. And so if you're using PowerShell, let me just do this right here. If you're using PowerShell in Windows, especially if you're at home, use this syntax. And so instead of export or set, you'll use that for PowerShell, especially if you're only Windows and modern VS Code. So just keep that in mind as we're using Ubuntu runners in this case, but we're going to be using the secrets management built into GitHub. Now, because you're using a free account, make sure you keep a public repo. No one's going to see your secrets. So once you create that repo, go to your settings, and then go down to secrets and variables, and then actions. And then what you'll do is you'll create a new repo secret, give it your variable name, and then you paste in your key. One important thing that if you use POE.com, make sure you pay for it. You'll have POE.com/API_key. I'm not going to show you because it'll show you my key, and I
Mhm.
want my stuff to work. And so, and then the Terraform runners. So the Terraform runner variables start off with the prefix of TF_var. Even though you reference just Sumo Logic access ID in the Terraform itself as that, you must prefix it in your OS with TF_var_ every time when
Mhm.
you're not using a Terraform specific runner. So basically, if you're using any Linux or Windows, you must prefix those with that. So that's something specific to Terraform itself. All right. So once we have that, we're just using essentially a ephemeral runner. And so even though it says runs on Ubuntu latest, look up how containers work. And it's just a bunch of essentially bash commands being ran. Use these to help you out tremendously in your pipeline. So these are the official checkout actions from GitHub itself. And then this is the one for setting up Terraform so you don't have to install it using apt-get. There's funky things that happen with ephemeral containers when you're using app install. And so if you use these as strictly from the vendor, they keep those up to date and you can lock it to a specific version in case they deprecate a feature for you. I also use the action setup for Python version 5, and they have caching. So as you deploy more detections, if you use cache pip, oops, if you use cache pip along with the requirements txt, and I froze these for you right here with the minimum requirements,
Yeah.
those will actually eat less into your billable minute time. So those are some quick tips for you. Those of you in the audience looking to do this at scale, this will help you save money in the long run.
Yeah.
Anyways, pip install just like you do like that. And because these are ephemeral, you don't have to use virtual environment. It already is its own virtual environment. And then simply with Terraform, we have their own built-in linting. So you can do a format check recursive, and it'll check all the folders there. Now there's a problem with this. You can't restrict which folders it does check. So basically, if you're at the top of the apex right here, it'll check every single folder. So
Mm.
be careful when you're doing that with Terraform, but it's a great starter plan for that. So if it fails somewhere right here, you're also failing a quote unquote unit test from
Mm.
that. The cool stuff is the synthetic testing. So the Python right here is where you're going to, and this is your deployment, obviously. Here's where your Python is, and all we're doing right here, and this is specific for you guys. Same thing here, right? Use your secrets keys and whatever, and then we build a prompt file. This prompt file is going to be our first introduction to RAG architecture, essentially. Now, it's not truly RAG architecture where we're grabbing every single BI of your organization, but this is a good start. So make Markdown and tell it stuff based on constraints. Talk to it
Mm.
like you're talking to um, I hate to say it, talking like you're speaking to management. And then just go ahead and set what your expected outcomes are looking like. And
Yeah.
you might have to play with this a little bit between multiple LLMs, but this is a good starter base for you. And I like to use qualitative because at the time of this recording, they don't give you good confidence intervals and numbers. It just doesn't
Mm.
compute quite literally. So it's that's what we're going to be doing is taking that prompt, giving it the use case itself. So our detections are right here, and Terraform uses modules, and everything is called from main.tf as a submodule. And so basically high, medium, low, and unknown. But more importantly, we are using two different LLMs based on the function calls right here. I'm using Gemini Pro. Gemini, I forgot what I said in there. There we go. All right, so I have a default of Claude 3.5 Sonnet. And then we have Gemini 5.1.5 Pro. It's like having two junior analysts investigating at the same time with a cursory review. And I do a
Yeah.
simple count here. It's not, I do essentially a string submatch count. I use the the forward slashes because it gives a good divider in case they give out extra comments. And then I simply set what my parameters are. So pass equals they're both high. I get a warn, which will still pass, but with a notice on the screen with a high and medium, and anything else we should fail it out because if the AI says it's wrong, you've really got it wrong.
Yeah.
Um,
Yeah. Question for
so
this
yeah, go
Python
ahead.
script. So you essentially like the what you have here is Claude and Gemini.
Hmm.
So given that the audience basically has access to this script and they're going to be actually putting this into their own repo, um, would you recommend them like editing this to like put their own desired
Oh yeah,
models like whatever they're interested in?
yeah. I would caution this. And I'll go to my POE account as well. There are other ones now beyond POE that do this sort of thing now that also have good introduction to AI bots. I would say put the markdown in here um, first, and then put the markdown and say, hey, and then give it an example of your use case. See what it outputs on based on what your markdown is before you waste runner time inside GitHub,
Mhm.
because these messages are practically free. Um, and then so you can test it with different. They call it bots, but it's really just custom ones versus ones that are official. I
Yeah.
selected these two, sorry, 3.5 and Gemini 1.5 because they were more consistently doing what I asked it to. When you
Mm.
use GPT 4.0 and Turbo, I've had a lot of different mixed results, and so it would not do what I asked it to do. So, yeah, test out different ones using chats first, and do that. If you want to take it to the next level, I did this. So you can create a new bot or chat yourself, and then
Mm.
what you can do is edit it. And there's something wrong with my Google Chrome. I don't understand why it does this. It closes the expansion for some reason sometimes. Use a bot type of prompt. Now you do some other cool stuff too. And then you have to give it a unique name. Put your markdown in here, and then you can upload your own reference KBs here. So this is kind of
Uh,
getting you closer to that RAG-ish architecture.
yeah.
And this might take you, I don't know, about 20 minutes to upload.
Mm.
I think it does better with Markdown and PDFs. So there is a 50 megabyte limit throughout your entire account. So don't upload too much. But once you do that, go to advanced. And then you can also override and set your temperature to what you're going to do inside the script. I'd set mine to about 0.15, and then and then I keep mine non-public most of the time for obvious reasons. And so what you can do is essentially test out what your runner is going to do. And
Right.
that's what I do as cheap as possible and as more frequent as possible. And then as you can tell, I use it a lot for giving it a different indicators and help and stuff like that. And I'm also creating exams, and so they do different things, and they greatly vary in their quality. So I found that Claude and Gemini do pretty well at code related analysis as opposed to some of the other ones. Cool.
Gotcha.
Okay, so I know we're feel like we're slowing down. Let's get
Mhm.
started on some cool stuff here.
All right.
One thing I wanted to point out, we're going to use a test detection case. There are some anomalies here, and you may not know why these are the case here for Sumo. It's just a Sumo Logic thing. I don't know what this is honestly yet, but I do know I've created something. You create in the GUI, you can export it as JSON, and then you
Hmm.
can get your format for Terraform from the provider that way. So more importantly, main.tf, if you ever wondered how to nest them and you get errors when you try to use multiple mains, it's because you have to use this format and reference it accordingly as a directory, not the actual Terraform itself. And then it'll reference all Terraform. You have to have this name and path the same as this, also reference, and then you have the provider put it inside the sub module instead. So interesting stuff. But let's get started on the cool stuff. So let's run it. So pretend that you're going to go in and upload all these files at the same time and commit to it. You can also delete and re-upload these as you want. I've included a test file in here. To be honest with you, I stole it from Splunk. They have a really good set of unit tests by themselves. So take a
Yeah.
look at their ESTU and find the log files. So those of you watching, that's where you can find them. So that's where our directories are set up. And there's more examples I gave to you right here if you want. I zipped them because they're in Terraform and I don't want it to recursively check everything. All right, so let's go to actions right here. And as you can see, I've already done one, but you can go right here and do the workflow file. I can do here. I'm going to do this one. And then usually when you're doing your first run, it'll let you do a right click and run job. But since I already ran it, it's going to go into the log. So I'm going to rerun the entire job.
Okay.
And the job is simply that section divider in that YAML. As you can see here, we're being charged based on whatever our output time is. And this is the same as if you did a git commit and git push. So
Right.
those of you who are perhaps new to Git commands in general, check out Atlassian. They have a great tutorial right here, especially when you're doing your first install with git config. And then you can actually see what the git commit and git push means. And basically, it's just copying your local repo to push to a remote repo, which is GitHub in this case.
Yeah.
Now that I've filled up a bunch of time as we waited for the log file to generate, here is exactly what it looks like. And I know that doesn't seem the most exciting thing, but once you get it working, it feels pretty good.
Yeah.
You'll get the plan out there with green. So if you see anything not green, that's bad.
Yeah.
And then of course you have your synthetic AI test here, which says, hey, I am using this. I parsed out essentially the detection only part from Terraform, and I'm using both, and they both say hi. And then I'm just going ahead and continuing without exiting as non-zero, and then it's deploying it. And then so in Sumo, we do a quick check here. Now the problem with this is there's two things that we don't do here. One, I don't keep state. So those of you who are coming from a cloud or Terraform background, we don't keep state in the script. You can, however, keep it back in state of S3 or another bucket of storage, but remember that you need to create the cloud connection using like an IAM key, but preferably an OIDC federated account. I do mention how do you connect those accounts in perhaps a different lab and a different article, but that's not for this time. So we go to alerts and monitor, and now we have two different use cases deployed. I have the one I call Terraform Log Monitor, which is like a default sample from the HashiCorp provider, and I have
Hmm.
tagging in here. And so, for those of you who are looking to do more with your threat-informed defense, tag
Yeah.
your use cases with your metadata so you can get the best out of it. And that's all it really is. Now I'm in, gives me exactly what I'm going to have in the GUI. And that's pretty much it. And you do a direct log search itself. And so as long as you have it working, you're fine. The problem is not just only state. It's deployed, but I don't know if it's really working or not, other than that synthetic test. So
Mm.
hopefully that makes sense to everyone out there. And let me know if you feel like you want to move on to something else right now.
Gotcha, gotcha. No, I think this was
Yeah.
like a pretty good breakdown. I think it would best serve the audience like when they actually go through that process by themselves. Like they set up the account, set up like the API keys, go through that deployment process. So they kind of get that experience with
Oh yeah.
actually like like I like in its simplest form, actually
Oh
doing
yeah.
detection as code. So I think that's good. And also it's always I was gonna say it's always good when you get a green on your action on your GitHub action. I have nightmares from previous life when those actions would fail, and just trying to figure out how to troubleshoot what exactly happened there.
That mysterious extra tab versus a space for YAML and something like that. Yeah.
Yeah,
It gets there. So for those of you out there, just follow what we have here, and then use the community documentation from the vendor for your exact step by steps. I don't want to give you step by step in the document because those change over time. But try it
yeah.
out. And if you have questions, reach out to myself. I'm not got the Dave's name out there, but I'm assuming you want them to contact you too.
Yeah,
Maybe.
no, absolutely. Like we're probably gonna have like I'm gonna probably go through this myself as well. So I'll probably have like a Discord chat going on for this. So like, if they need any help, I can, kind of help out with it. I also think another call out would be this was specifically designed for Sumo. But I think it's also like,
Oh
the
yeah.
onus is also on the audience members to also like try to experiment with let's say another, another sim, like, another platform that might have this capability and just kind of like test out what the possibilities are with actually doing this kind of like detection as code implementation or pipeline deployment.
Absolutely. I do think there another popular one that most of the people that are at least working in the field have Splunk or have some form of version of it. Instead
Hmm.
of an API with Terraform, you'll use content control, and they have a new blog posting out there that says how to use it. You'll package up an app and push it instead. The
Mm.
problem is you'll have to have, if you're in the Splunk cloud, you have to have AWS backed. You can't be GCP backed, and then you need to have certain more than just the search. You have to have the management control and ACS modules too.
Mm.
So just keep that in mind moving forward. But yeah, as long as there's an API, I think the golden rule is if there's an API with most security tools are DSL or domain subject language.
Yeah.
Um, and so because you already have that, everything could be detection as code. The
Hmm.
only exception is there must be an API.
Yeah.
Um, yeah, to
I'll be
to
surprised if,
to
like,
the detection.
yeah, I'll be like, I think, like with, detection as code, like being, oh, and this is probably another conversation, but with detection as code, I guess getting a lot more, popular these days, like it would be actually surprising if, like, any mature SIM out there doesn't have an API you can use for that. Like that's probably like going to be a major um, selling point for, organizations that want to implement like a pipeline for the detections.
Oh yeah. I think most modern sims are trying to catch up. I don't think you'll be getting anything out of QRadar or some of these other ones that don't want to get to that level. But yeah, I would say those of you that are fresh or brand new building your first scenes, yeah, find something cloud native. If it makes sense to your budget and everything, because they more than likely have an API to manage not just the administration part, but the detection part.
Yeah.
Yeah, cool.
Gotcha. Now let's hop into the second lab where we go over some policy as code testing and essentially use the same detection as code engineering mindset and practice to test cloud infrastructure compliance and security controls. This lab will demonstrate how we can automate policy enforcement and validation using Cloud Custodian in a GCP environment. All right, then let's move on to the second one.
Cool.
So
Yeah, let's do that. So, and this one, so we're going to use Cloud Custodian. Again, this will all be kind of set up for you already. Same thing going on. Well, because we walked through all this stuff already, I'll be a little faster on this, but know that Cloud Custodian is a really awesome tool for CSPM stuff. So if you want to write your own compliance as code or policy as code, that's a good place to start if you don't have much coin on you. Now we're
mm,
going to do something a little bit different. I'm going to use, you and I are AWSers or Amazonians at heart, and yourself recently too. But GCP is something I think some people have an easier time getting their feet wet on. And so once
yeah,
you create your GCP account, everything's called a project. Your account is tied to your Gmail identity, at least at first. Make sure you finish through the setup process. And then there's two distinctions. There's the user-friendly name, and then there's the project ID name they give you. I had something called accept demos and another account, and so they gave me a suffix right here. So this is actually your project ID
hmm
when you actually reference it inside your environment variables. Very important to keep in mind. So for here, I want you guys to go to IAM right here. You just type it in. You might have to click on something like enable API or click a blue
yeah,
button that does it here. Depends on your stuff. I want you to create a new I'm having a blank out here. I'm sorry about that.
service
Service
principal.
accounts. There we go.
Yeah,
Yeah, and then create the service account. I called mine whatever here. You're gonna go ahead and click on that, and we're gonna do something that's not very security centric. We're gonna go ahead and make a long-term key. Now, this long-term key is a JSON key that is tied to this service account emulation here. Now you create the permission of your service account. Make sure you give it the owner role, which means super admin of this account. So basically create a new account. Don't use a production account for this
yeah,
purpose. Create the new key. Once you create the key, you're going to use a JSON format, and it creates a JWT, and you'll download it, and it won't show up again. So make sure you download it and delete it securely the first time after we deploy it inside the GitHub. Now, the real way to do this is, again, the OIDC method. I think I'll show you guys how to use it. But AWS has a really good one for GitHub. So just look up OIDC and like GitHub and whoever your CSP is. And then chances are they'll have a really awesome tutorial for you. But because it's so much more involved, including mappings, we're not going to be doing that. So, but this is going to accomplish the same thing, only fail safe because we're super admin.
yeah,
All right. The other thing before we move onward is one thing I don't do is create a Terraform thing for you because it's just such a small project. There is a there's a yeah there's a PubSub cloud storage subscription version, and there's a regular one. They're going to separate those APIs at some point or merge them at some point. just
That
just
looks
stream.
pretty new. Because the last
Yeah,
time I used PopSub, it didn't have that.
yeah, they're trying to go in full stream mode. It's kind of cool. I found, yeah, again, as much as I'm an AWS or GCP services are just nice and easy to use out of the box. Create a new pub sub, and what you do is create a subscription type. Now let it do its defaults, and this will create all the defaults tied to this project, and that's all you really need. And so what we're going to do is we're going to pull messages from there. Now it'll come into a pub sub message uses like a special format. It's not just an ASCII or something, so it has to be decoded using multiple rounds. Um, and so from PubSub, you can trigger something or do something else, which is cool. But we're not going to do that. We're not going to do reinforcement. That's for you to deploy Cloud Custodian in prod. We're going to do purely the pipeline of deploying um, the test and detection based on that. Last thing that I want to show you in the project itself, and I forget my terms sometimes because between different CSPs. Cloud storage is the S3 bucket over there. I'm calling mine foobar CWX GCP demo. I'm not tagging it. It's just I create it. It's free. You don't have to worry about paying anything out of it. Okay, so now that we have that all established, once you've done that, just like you do the last time, create yourself a new repo, upload and commit those, and then your actions will just be make sure you call it the same as mine, GCP's SA key, new repository secret, and then you paste your secret in there, which is essentially the JWT, but make sure you only paste the private key. So make sure you only paste the private key, nothing else in there. Once you've done that, let's go ahead and trigger this guy. And the only difference is, actually, I'll trigger that, the workflow file, rerun all jobs. And while that's going, I want to show you, this is pretty easy stuff to do. I have two different scripts this time.
Okay.
I have the integration test itself and then the CC deployer. CC deployer is a wrapper script for everything. That's kind of like acting as, this is the thing that the GitHub Action Runner will run at first, and then it'll run through essentially running a custodian after installing it from Python. And then it'll run its own syntax and try run test, which is unit testing. So this is more of like an integration 1.5 test. It's not a true integration test, but it's also it's not lesser than a unit test. And then we'll call the integration test thereafter. So after we run our dry run test, which is actually simulating a real run as opposed to a synthetic test itself, Cloud Custodian not only does syntax checking and formatting with its schema, but the dry run format with a -d in there will let you actually simulate it in your account, but not actually make those changes. So, and this policy path is just ephemeral. You have to have it. Depends on your version. I've got some other stuff in here too, specifically using the gcloud command. So you'll see in the GitHub runner, I do the checkout for it or the installation for it. This is the syntax that needed after some time. And then I'm going to have a integration test here. Now, once you do a integration test here, I'm doing two things. I'm deploying it initially, so actually getting it deployed. And so we remember integration testing in our world always means post deployment because you have to test it thereafter. So I'm going to grab the YAML, and what's specific about Cloud Custodian in our case is that it does whenever Cloud Custodian creates a message that goes to PubSub. Right now, the developers have made it into a JSON serialized JSON that's a zlib compressed, and then basically encoded with padding. And so, admittedly, I kind of cheated. I used Claude to help me with the like giving the reverse of that.
That's
And
a
then
lot.
it gave me that, so it wasn't bad. So once I got all that going, it gave me the we'll check PubSub itself, and so we'll use the decoded message that we can see in PubSub, looking for the policy name. And the policy name is right here. And so it'll
Right.
give you a copy of all this and all this other sweet metadata. If you're running this manually, I'm giving you the equivalent of running this in Cloud Shell inside GCP.
Yeah.
Just know that I had trouble with GCP and they decided not to help me. So you may be banned from CloudTrail for some reason. I don't know. But it wasn't like they give you no explanation. So you'll never get support from them. So if it doesn't find that policy name, which means it didn't run successfully, go ahead and fill it out as an exception raise.
Mm.
And then I do a dump on there. That's all it really is. And so you can also do some additional stuff beyond that. So deploy plus test, and that's in run script too. So I have nested scripts in there because it was just easier to kind of show you guys versus make multiple function blobs
Yeah.
going on. Okay, cool. So with that said, let's look at our action here. No, did it run? Oh, it did.
Oh, there you go.
Okay, yeah, I was a little worried there. So our usage is built on 1 minute and 22 seconds so far. I think I ran it twice for some reason. I don't know. And so you can see here again, this is not anything crazy. It's only as exciting as your output to print out.
Mm-hmm.
So you can do some major debugging here, but remember that you get charged based on time. So the more time you spend writing out to standard out, the more time technically it takes. So if you have large projects that compile,
Yeah.
this is a big deal too if you're having too much verbosity. So it's probably not going to be for us. I think I did some basic info debugging level here from Cloud Custodian with very verbose. So if you have problems with your custom tests, in our case, I deployed a custom test. What do I call it? I shouldn't have done that. All right. So our custom test in this case was a find untagged buckets. And then in theory, you could have an action that says automatically redeploy or reinforce it down here.
Yeah.
That really depends. You would have to put notify actions after your reinforcement action or beforehand, depending on how you want the order tested.
Mm-hmm.
So that's where it goes inside your parsing there. That's all it means. I think one thing I'd like to say is the build spec thing. What's different from build spec in the last one? Let me show you the difference. And I know this doesn't seem interesting for now, but hold on. There is a, yeah. Now the way I did it here is key value pairs, and it's easier for the detection engineer to say 1-to-1. So
Mm.
tell that test, and this is the path, and do something on this and just parse that
Okay.
from the script. So I'm parsing that from the script in here. The difference in this one is that I use a list format. And instead of having multiple key value pairs, for something as policy as code, everything itself, it's a self-enclosed test. And so for something like this, maybe you use a list instead. So in that way, instead of having one policy at a time, testing it, iterating it over and over again, I test it all in one go.
Right.
And
So
then
you could add like multiple other ones to this list.
yeah, so you can have like, a gazillion other YAML files from the Cloud Custodian, whatever applies to you. And the beauty behind that's why I have nested scripts in here. I do the integration test by itself. It's just the 1-for-1. Basically, give me input and I get that one output. And notice I don't have any loops. And actually, I do have a loop. I notice I have a loop in here for input JSON, and then the
Right.
JSON is the looping of essentially the path names to all detections tests, and it's going to continue doing that right there. If you don't have that iteration, then you're kind of putting in many more commits than you want to.
Yeah.
So if you're scaling out as a team, you'll want to do that. And so as after verbosity here, it's giving us the Google Cloud information, and then of course my output here is policy name match found, and this says continue performing that full test in there. I give you guys, if you're wondering why there's some decoding and what it looks like without the decoding, I give you guys the examples here, and then there's
Oh,
I give
okay.
you the original decoded Python if you were to run it from standard in, that I was dinking with on my own, and then I give you the JSON encoded message that comes from my project. This is what gets sent out. So this is what gcloud will actually output
Right.
when using PubSub, and so you have to decode this stuff.
Decode that. Yeah.
Yeah, and so even though it's in the naked eye, it looks like base64. I'm just going to cheat using CyberShell because then you'll see that it'll find it's not going to do it well. And so if you do base 64 zlib inflate, so basically if you do basically two base 64 and then zlib inflate as the recipe,
Hmm.
you'll see the fully decoded thing. And I'll just, because we have time, why not? Um, two from base 64. Okay. And then now this is the important part. If you got URL safe encoding. So there apparently is a subsection RFC. So I learned something new of the base 64 encoding parameter. So if you're looking for something and if your base 64 encoding, decoding mechanisms don't work, it's probably because you're using a URL safe edition, which is subsection
Mm,
5.
it's interesting.
So yeah, I didn't know about that till like when I did this. And so, yeah, and so you do zlib inflate. Now you see everything that the bucket, the policy is executed, the value of it. So if I wanted to test the value beyond the policy just executed successfully, like the value test or something like that,
Yeah,
using this kind of mechanism for decoding, I can parse through the JSON
yeah,
in its different key value pairs accordingly. And so that's really what I wanted to show you today. Hopefully you guys found it, useful, and I hope you extend or do something cool with that.
yeah, yeah. Absolutely. I think the cool thing about this is like you gave it out as like a template, right? The cool thing about it is you can play around with this. For example, like the GCP one, like you can look for other possible like policies, like policies for identities, right? So like maybe an identity having whatever, like maybe tagging for this one, but maybe like specific things for an identity or for compute or
Yeah,
for specific resources, and then kind of play around with that, and then essentially create your own project out of this, because like it's pretty modular in the way it works. So I think that's pretty cool.
cool. Yeah. Well, if you guys want to learn more or something like that, just reach out, and we're happy to talk about it. And tell us what you've done with these projects. If you do anything with it, like if you extended it or do something cool with it. So I'd love
Yeah.
to hear about what's going on out there besides me talking.
Yeah, no, same as me. But I appreciate you doing this, Dennis. It's really cool. I will be looking forward to making this video, putting it out there, and just kind of seeing, like you said, what people do with it. How they play around with it, and probably have conversations about it within the Discord as well. But thank you so much for doing this, Dennis. And by the way, like I said, if you want to get more context into what we just talked about here, definitely check out the podcast as well as the book, which will both be linked in the description below. All the details as well will be linked in the description below, including the GitHub repo and Dennis details as well. But again, thank you so much for doing this, Dennis. I appreciate your time.
All right. Thank you.
All right, thanks for watching, and I'll see you in the next video. Bye-bye. Thank you so much for watching this episode. In the meantime, you can check out the other videos in the Detection Opportunity series over here, or the next video right over here. I'll see you there.